Ladies and gentlemen, imagine a world where the trucks that move everything you depend on are no longer loud, slow, or wasteful, but intelligent machines that think, adapt, and optimize every mile they travel. Imagine a vehicle that pulls a full load uphill without hesitation, recharges faster than a coffee break, and costs less to run every single day it's on the road. This is not a concept, not a promise for the distant future. This is a fundamental shift in how freight moves, how energy is used, and how efficiency is redefined. What you're about to hear isn't just an update on a truck, it's a glimpse into the future of global transportation. And the Tesla Semi 2026 update represents a clear step forward in how heavy-duty transportation is designed, built, and deployed at scale. From the ground up, this vehicle is engineered with a single objective: to move the most cargo, with the least energy, highest reliability, and lowest total cost of ownership. Every system, every material choice, and every line of software has been refined to serve that purpose. And at the core of the 2026 Semi is efficiency. The vehicle is designed around an aerodynamic profile that dramatically reduces drag compared to conventional diesel trucks. The central driver position improves visibility, balance, and safety, while also enabling a more symmetrical airflow around the cab. Small design details, flush surfaces, optimized mirrors, and integrated fairings combine to reduce energy consumption mile after mile. The result is a truck that requires significantly less energy to move the same payload over the same distance. And powertrain improvements define the heart of the update. The electric motors, derived from high-performance passenger vehicle platforms and adapted for heavy loads, deliver instant torque with no gear shifting and no loss of power on inclines. Even at full gross vehicle weight, acceleration remains smooth, predictable, and quiet. The drivetrain is engineered for redundancy, allowing the vehicle to continue operating efficiently even if a motor module is offline. This architecture increases uptime and reduces the need for emergency service interventions. And battery technology in the 2026 Semi reflects years of continuous refinement. The pack is designed for extreme durability, with improved thermal management that maintains optimal operating temperatures across a wide range of climates and duty cycles. Fast charging capability enables rapid energy replenishment during mandatory driver breaks, aligning charging time with existing logistics schedules. For fleet operators, this means minimal disruption and maximum utilization of each vehicle. And range performance is not presented as a single abstract number, but as a practical capability measured under real-world conditions. Long-haul configurations are optimized for extended routes, while regional haul variants focus on repeated daily cycles with consistent efficiency. Advanced energy management software constantly adapts to terrain, load, weight, traffic patterns, and weather, ensuring that every kilowatt-hour is used as effectively as possible. And reliability is a defining feature of the Semi program. Fewer moving parts compared to internal combustion trucks translate into fewer failure points. There is no engine oil, no transmission fluid, no exhaust system, and no emissions control hardware. Maintenance schedules are simplified, downtime is reduced, and operating costs become more predictable. Over the lifetime of the vehicle, these factors compound into substantial savings for fleet owners. And the driver experience is central to the 2026 update. The cabin is designed as a workspace rather than a traditional cockpit. Large displays provide real-time information about navigation, energy usage, vehicle diagnostics, and safety systems. The seating position reduces fatigue on long routes, while the low noise and vibration levels create a calmer driving environment. Enhanced driver assistance features support lane keeping, adaptive speed control, and collision avoidance, helping reduce stress and improve safety outcomes. And safety engineering extends beyond the driver. The Semi structure is built to absorb and distribute impact forces in ways that protect both occupants and other road users. The low center of gravity enabled by the battery placement significantly reduces rollover risk. Advanced braking systems, including regenerative braking, provide consistent stopping power, even under heavy loads, while also recovering energy during deceleration. And manufacturing scalability is a critical part of the 2026 update. The Semi is designed to be produced efficiently at high volume using modular components and streamlined assembly processes. This approach supports rapid deployment across diverse markets while maintaining consistent quality. Continuous feedback from early fleet partners has been integrated into production refinements, ensuring that real-world usage informs every iteration. And charging infrastructure is addressed as part of the complete system. High-power charging solutions are designed specifically for commercial operations with layouts that accommodate large vehicles and trailers. On-site energy storage and solar integration enable fleets to stabilize energy costs and reduce dependence on peak grid pricing. This ecosystem approach ensures that the Semi is not just a vehicle, but part of a broader energy and logistics solution. And from an environmental perspective, the impact of the 2026 Semi extends far beyond tailpipe emissions, because there are none. When paired with renewable energy sources, the life cycle carbon footprint of freight transport is dramatically reduced. Urban air quality improves, noise pollution decreases, and communities benefit from cleaner, quieter roads. For companies with sustainability goals, the Semi becomes a direct and measurable tool for progress. And data and connectivity play an increasingly important role. The Semi continuously collects operational data that helps optimize routes, predict maintenance needs, and improve overall fleet performance. Software updates are delivered over the air, adding new features and performance improvements without requiring service visits. This ensures that vehicles on the road today continue to improve over time, extending their value well into the future. And the economic case for the 2026 Semi is built on total cost of ownership rather than upfront price alone. Energy costs per mile are significantly lower than diesel, maintenance expenses are reduced, and vehicle uptime is increased. When these factors are combined with incentives, regulatory benefits, and long-term fuel price stability, the financial advantages become clear for both large fleets and independent operators. And the 2026 update reflects a broader shift in how transportation systems are conceived. Instead of incremental changes to legacy designs, the Semi is built around first principles, physics efficiency, and software integration. It demonstrates that heavy-duty transport can be both high-performance and sustainable without compromise. And this vehicle is not positioned as an experiment or a niche product, but as a foundation for the future of freight. It is designed to operate reliably in demanding conditions, scale globally, and integrate seamlessly into modern logistics networks. Every update, every refinement, and every deployment reinforces the same idea: the future of trucking is electric, efficient, and engineered as a complete system. And it is built to challenge long-standing assumptions about what heavy-duty vehicles can be and to redefine expectations across the entire freight industry. By focusing on first principles engineering, the platform continues to evolve in ways that conventional designs cannot easily replicate. Each update is informed by real-world data collected from active fleets, ensuring that improvements are grounded in actual operational demands rather than theoretical benchmarks. And the 2026 iteration places a strong emphasis on energy intelligence. The vehicle does not simply consume power, it actively manages it. Predictive algorithms analyze route elevation, traffic density, weather conditions, and payload distribution to determine the most efficient power delivery strategy in real time. This intelligence allows the Semi to anticipate energy needs before they arise, reducing unnecessary consumption and extending usable range under variable conditions. For operators, this translates into greater confidence when planning long routes and tighter delivery schedules. And thermal management systems have been further refined to handle sustained high-load operation. Whether climbing long gradients, operating in extreme heat, or navigating cold weather environments, the battery and drivetrain remain within optimal temperature ranges. This stability improves both performance, consistency, and long-term component health. The result is a vehicle that performs predictably regardless of geography, making it suitable for global deployment without extensive regional modifications. And durability has been engineered into every structural element. The chassis is designed to withstand millions of miles of operation, with materials selected for strength, corrosion resistance, and fatigue tolerance. Suspension systems are tuned to balance ride comfort with load stability, protecting both the cargo and the vehicle itself. Over time, this resilience reduces wear-related failures and extends service intervals, further lowering lifetime operating costs. And the braking system reflects a holistic approach to safety and efficiency. Regenerative braking captures kinetic energy during deceleration, converting it back into usable electrical energy while reducing wear on mechanical brake components. This not only improves energy efficiency, but also extends brake life, a critical factor for heavy trucks operating in stop-and-go or mountainous environments. When mechanical braking is required, the system delivers consistent, predictable performance under all load conditions. And connectivity between vehicles and fleet management platforms has been enhanced. Operators gain access to detailed insights into vehicle health, energy usage, and driver behavior through secure digital dashboards. These insights enable proactive maintenance scheduling, optimized routing, and improved driver training programs. By identifying inefficiencies, early fleets can make data-driven decisions that improve overall productivity and reduce unexpected downtime. And the Semi's integration with autonomous and driver assistance technologies continues to mature. Advanced perception systems monitor surrounding traffic lane markings and road conditions with high precision. These systems assist drivers by reducing cognitive load during long hauls, supporting safer lane changes, maintaining safe following distances, and responding rapidly to potential hazards. Over time, these features contribute to lower accident rates and reduced insurance costs. And interior ergonomics have been refined based on extended driver feedback. Controls are positioned for intuitive access, displays are optimized for quick comprehension, and cabin storage solutions are designed to support long-duration trips. Climate control systems operate efficiently without excessive energy draw, maintaining comfort in both hot and cold conditions. The overall environment supports alertness and reduces fatigue, which is essential for safety and productivity. And the supply chain behind the Semi has been optimized for resilience and scalability. Vertical integration of key components reduces dependency on external suppliers and improves quality control. This approach enables faster iteration, tighter tolerances, and more consistent performance across production runs. As manufacturing volumes increase, economies of scale further reduce costs, making the platform accessible to a wider range of operators. And energy infrastructure continues to evolve alongside the vehicle. High-capacity charging installations are designed to support multiple trucks simultaneously without compromising charging speed. Intelligent load balancing ensures efficient use of available power, while integration with on-site energy storage smooths demand peaks. This infrastructure strategy allows fleets to expand electrification without overwhelming local grids. And environmental benefits extend beyond emissions reduction. The quiet operation of electric trucks reduces noise pollution, particularly in urban and residential areas. This enables more flexible delivery schedules, including nighttime operations, without disrupting communities. Reduced vibration also contributes to lower road wear, potentially decreasing infrastructure maintenance costs over time. And regulatory alignment is another advantage. As emission standards tighten globally, electric freight vehicles are positioned to meet or exceed future requirements without additional modifications. This future-proofing protects fleet investments and reduces the risk associated with regulatory uncertainty. Incentives and credits in many regions further enhance the financial case for adoption. And the Semi's software-defined architecture ensures that performance improvements are not limited to hardware changes. Over-the-air updates deliver enhancements to energy management, navigation, safety systems, and user interface functionality. This continuous improvement model means that vehicles in service today benefit from advancements developed tomorrow, extending their relevance and value over many years. And operational flexibility is a key outcome of the 2026 update. The platform supports a wide range of use cases from short-haul distribution to long-distance freight corridors. Modular configurations allow operators to tailor the vehicle to specific payloads, route lengths, and charging strategies. This adaptability reduces the need for multiple specialized vehicle types within a single fleet. And the economic model continues to focus on predictability. Electric energy pricing is generally more stable than fossil fuel costs, allowing for more accurate long-term budgeting. Reduced maintenance variability further stabilizes operating expenses. When combined with high vehicle uptime, these factors improve cash flow and return on investment. And from a broader systems perspective, the Semi represents a shift toward integrated transportation solutions. Vehicles' energy infrastructure, software platforms, and manufacturing processes are designed to work together seamlessly. This integration reduces friction at every stage, from production and deployment to daily operation and long-term ownership. And the 2026 update reinforces the idea that progress in heavy transportation does not require compromise between performance, efficiency, and sustainability. Instead, it demonstrates that aligning these priorities through thoughtful engineering can produce outcomes that surpass traditional expectations. Each mile driven generates data, each update refines performance, and each deployment contributes to a growing network of electric freight operations that continuously improve as a whole. And the platform's evolution is guided by the principle that the best solution is one that scales. Scalability is built into the design, the manufacturing process, and the supporting infrastructure. This ensures that as demand grows, the system can expand without sacrificing reliability or performance, enabling a rapid transition toward a more efficient and sustainable freight ecosystem. And this scalability is reinforced through continuous learning across the fleet, where aggregated performance data informs design decisions, software refinements, and operational best practices. Each vehicle contributes to a broader understanding of how electric freight behaves under diverse conditions, allowing the system to evolve faster than isolated development cycles ever could. This feedback loop accelerates improvement while maintaining consistency across deployments. And grid interaction has become more sophisticated in the 2026 update. The Semi is designed not only to draw power efficiently, but also to interact intelligently with energy systems. Smart charging enables fleets to align charging schedules with periods of lower demand or higher renewable energy availability. This reduces energy costs and supports grid stability, transforming large fleets from passive consumers into active participants in the energy ecosystem. And battery longevity remains a central focus. The chemistry and pack architecture are optimized for high cycle durability, enabling repeated fast charging without significant degradation. This is especially critical for commercial operations, where vehicles are expected to operate daily with minimal downtime. By preserving battery health over extended service life, the platform reduces replacement costs and minimizes resource consumption over time. And the integration of route planning with charging infrastructure continues to mature. Navigation systems automatically factor in charger availability, charging speed, elevation changes, and real-time traffic conditions. This ensures that routes are not only the fastest, but also the most energy efficient and operationally reliable. For drivers, this removes uncertainty and simplifies long-distance planning. And operational safety extends beyond collision avoidance. The Semi actively monitors tire health, brake performance, suspension load balance, and electrical system integrity. Early detection of anomalies allows issues to be addressed before they escalate into failures. This predictive approach shifts maintenance from reactive to proactive, increasing reliability and reducing unplanned service interruptions. And cabin technology reflects a software-first philosophy. Interfaces are designed to minimize distraction while maximizing situational awareness. Visual cues, alerts, and performance metrics are presented clearly and contextually, ensuring that drivers receive the right information at the right time. Voice control and steering wheel inputs reduce the need for manual interaction, further enhancing safety. And the physical design supports efficient ingress and egress, reducing strain during frequent stops. Visibility improvements reduce blind spots, while camera-based systems provide enhanced awareness around the vehicle. These features contribute to safer operation in urban environments, distribution centers, and loading docks where precision is critical. And supply chain emissions are addressed through manufacturing choices and logistics optimization. Materials are selected not only for performance, but also for recyclability and reduced environmental impact. Manufacturing facilities increasingly rely on renewable energy, lowering the embodied carbon footprint of each vehicle produced. This systemic approach ensures that sustainability is embedded throughout the life cycle, not just during operation. And as adoption increases, network effects begin to emerge. Shared charging infrastructure becomes more cost-effective, standardized components simplify servicing, and collective data insights accelerate innovation. This interconnected ecosystem benefits all participants, from individual owner-operators to large logistics providers. And the semi's role within multimodal logistics is expanding. Integration with rail ports and distribution hubs enables seamless transitions between transport modes. Electric freight vehicles excel in short-haul and last-mile operations, while also supporting long-haul routes where charging infrastructure is established. This flexibility allows logistics networks to optimize each segment for efficiency and cost. And weather resilience is another area of advancement. Improved traction control, torque vectoring, and stability systems enhance performance in rain, snow, and icy conditions. Consistent power delivery and low center of gravity contribute to predictable handling, reducing risk during adverse weather events. And noise reduction continues to deliver operational advantages. Quiet operation enables compliance with stricter urban noise regulations and supports extended delivery windows. This flexibility improves asset utilization and reduces congestion during peak hours, benefiting both operators and communities. And training and onboarding are streamlined through intuitive design and digital support tools. Drivers transitioning from conventional trucks adapt quickly due to simplified controls and responsive handling. Digital training modules informed by real-world usage patterns support continuous skill development and reinforce safe, efficient driving practices. And the financial model continues to improve as scale increases. Declining battery costs, manufacturing efficiencies, and optimized supply chains contribute to lower vehicle pricing over time. Combined with reduced operating expenses, this accelerates the point at which electric freight becomes the default economic choice rather than an alternative. And resilience against fuel price volatility provides strategic advantages. Electricity pricing is generally more stable and predictable than fossil fuels, enabling long-term planning with greater confidence. This stability is particularly valuable for logistics contracts that span multiple years and require cost certainty. And the semi's modular architecture allows future upgrades without requiring complete vehicle replacement. Components such as power, electronic sensors, and interior systems can be updated as technology advances. This upgradability protects investments and ensures that fleets remain competitive as standards and capabilities evolve. And global adaptability is built into the platform. Variants can be configured to meet regional regulations, payload requirements, and infrastructure constraints. This enables deployment across diverse markets while maintaining a consistent core design philosophy. And as the freight industry transitions toward electrification, the semi functions as both a vehicle and a catalyst. It challenges existing assumptions about performance, reliability, and cost, demonstrating that electric solutions can exceed the capabilities of traditional platforms. Each deployment reinforces confidence, encourages infrastructure investment, and accelerates broader adoption. And the system-level approach ensures that progress in one area amplifies benefits in others. Improvements in battery efficiency enhance range, which reduces charging frequency, which improves uptime and lowers costs. Software refinements enhance safety, which reduces accidents, which improves operational reliability, and lowers insurance expenses. These compounding effects define the platform's long-term advantage. And through continuous iteration, real-world validation, and integrated design, the Semi evolves as a living system rather than a static product. Every mile contributes to refinement, every update unlocks new capability, and every deployment strengthens the foundation for a freight network that is cleaner, quieter, more efficient, and engineered for the demands of a rapidly changing world. And the evolution continues through an uncompromising focus on optimization at every layer of the system, where hardware and software are treated as a single inseparable platform. This philosophy allows rapid adaptation to new challenges as freight patterns shift, urban density increases, and energy systems modernize. The vehicle is designed to anticipate change rather than react to it, ensuring long-term relevance in an industry that demands reliability above all else. And as real-world usage expands, performance modeling becomes increasingly precise. Machine learning systems analyze millions of miles of operational data to identify subtle efficiency gains, refine power delivery curves, and enhance predictive maintenance algorithms. These insights are deployed across the fleet through software updates, meaning that improvements discovered in one region benefit vehicles operating everywhere. This collective intelligence transforms scale into a competitive advantage. And charging behavior continues to evolve with deeper integration into logistics planning. Instead of treating charging as downtime, fleets schedule energy replenishment as a routine part of operations, synchronized with loading, unloading, and mandatory rest periods. High-power charging technology ensures that even brief stops can deliver meaningful range, reducing the need for extended charging sessions. This alignment preserves productivity while supporting long-haul electrification. And energy storage strategies extend beyond the vehicle itself. Fleet depots increasingly integrate stationary storage systems that buffer energy during off-peak hours and release it during high-demand periods. This approach reduces peak demand charges and enhances resilience during grid fluctuations. By pairing vehicles with on-site energy systems, operations gain greater control over costs and availability. And material science plays a growing role in the platform's development. Lightweight composites, high-strength alloys, and advanced coatings contribute to durability while minimizing mass. Every kilogram saved improves efficiency and payload capacity, compounding benefits over millions of miles. These material choices are guided by life cycle analysis, ensuring that performance gains do not come at the expense of sustainability. And manufacturing processes are continuously refined to improve consistency and throughput. Automation and precision tooling reduce variability, while real-time quality monitoring ensures that each vehicle meets exacting standards. This manufacturing discipline supports rapid scaling without compromising reliability, a critical requirement for fleet customers who depend on predictable performance. And service and support models are evolving alongside the vehicle. Remote diagnostics enable technicians to identify issues before they affect operation, often resolving them through software adjustments rather than physical intervention. When service is required, modular components allow for quick replacement, minimizing downtime. This approach shifts the service experience from reactive repairs to proactive optimization. And the driver's role continues to be redefined. Advanced assistance systems reduce workload during monotonous highway driving, allowing drivers to focus on situational awareness rather than constant control inputs. As these systems mature, they enhance safety and consistency while preserving human oversight. The goal is not to replace drivers, but to augment their capabilities and reduce fatigue-related risks. And operational transparency benefits both drivers and fleet managers. Clear feedback on energy usage, driving efficiency, and system performance fosters a culture of continuous improvement. Drivers gain insight into how their actions affect range and efficiency, while managers can identify best practices and share them across teams. This alignment improves outcomes without relying on rigid enforcement. And urban integration becomes increasingly important as cities adopt stricter emissions and noise regulations. Electric freight vehicles operate comfortably within these constraints, enabling access to zones that restrict conventional trucks. This access supports faster deliveries, reduced congestion, and improved air quality, strengthening relationships between logistics providers and municipalities. And global logistics networks benefit from standardization. A consistent electric platform simplifies cross-border operations, training, and maintenance. As charging standards and energy systems converge, interoperability improves, further reducing barriers to adoption. This harmonization supports international freight corridors designed around efficiency rather than fuel availability. And resilience against external disruptions continues to strengthen the business case. Reduced dependence on fuel supply chains insulates operations from geopolitical volatility and price shocks. Local energy generation and storage further enhance independence, enabling fleets to maintain operations during disruptions that would affect conventional vehicles. And the platform's adaptability extends to emerging use cases. As autonomous logistics, smart highways, and connected infrastructure develop, the vehicle is designed to integrate seamlessly. Sensor suites, compute capacity, and software frameworks are already in place to support these advancements as they become viable at scale. This forward compatibility ensures that today's investments remain valuable as technology evolves. An environmental impact is measured holistically. Reduced emissions, lower noise, and improved energy efficiency contribute to healthier communities and ecosystems. Over time, these benefits accumulate, supporting broader climate and sustainability objectives. For organizations committed to environmental responsibility, electric freight becomes a tangible expression of those values. And the economics of electrification continue to improve as adoption accelerates. Learning curves drive down costs, while increased production volumes unlock efficiencies across the supply chain. Financing models evolve to reflect lower operating risk and predictable expenses, making adoption accessible to a wider range of operators. And policy alignment further accelerates deployment. Governments increasingly recognize the societal benefits of zero-emission freight and support adoption through incentives, infrastructure investment, and regulatory frameworks. These measures reduce friction and encourage faster transitions without compromising safety or reliability. And the relationship between vehicle and infrastructure becomes more symbiotic. Data sharing between charging networks and fleet systems improves availability and planning, reducing congestion at charging sites. Predictive models anticipate demand and guide infrastructure expansion, ensuring that capacity grows in step with vehicle deployment. And as experience accumulates, best practices emerge that redefine industry standards. Maintenance intervals, energy management strategies, and route optimization techniques evolve based on empirical evidence rather than tradition. This evidence-based approach drives continuous improvement and raises expectations across the sector. And the platform's success reinforces a broader shift toward systems thinking in transportation. Vehicles are no longer isolated assets, but nodes within an interconnected network of energy, data, and logistics. Optimizing the system yields benefits far greater than optimizing individual components in isolation. And long-term durability remains a defining characteristic. Components are designed not only to perform well initially, but to maintain performance over extended service life. This longevity reduces waste, conserves resources, and maximizes return on investment. Vehicles are built to work hard, adapt continuously, and remain relevant through years of technological change. And as deployment expands, confidence grows. Early adopters validate performance, infrastructure matures, and operational knowledge deepens. Each successful operation encourages others to follow, creating momentum that accelerates the transition to electric freight. And the result is a platform that evolves through use, improves through data, and scales through integration. It demonstrates that heavy-duty transportation can be efficient, reliable, and sustainable without sacrificing performance. Every advancement builds on the last, reinforcing a trajectory toward a freight ecosystem designed around intelligence, resilience, and efficiency at scale.